Welcome to this edition of Math Dive in About 5. Today we'll be focusing on unit conversions. I'm Barbara Knox. On the next slide, you're going to see some conversions that we're going to ask you to make. For each conversion, we want you to write an equation with a variable that represents the missing value. And consider what students are going to need to know and understand in order to be able to solve problems like these, and what misconceptions might occur. See you back in a few. All right, we're going to take a quick look at the progression with BEST. We know measurement starts way back in kindergarten.
Yeah, right. In the K2 band, they are measuring with non-standard units, so it's not like they've never thought anything about measurement before.
And they do measure with inches and centimeters in first and second grade.
Yes. Right. But conversions come later.
Conversions actually start in fourth grade, and this year with the BEST standards, in fourth grade they are actually multiplying and dividing with conversions, which is new for fourth grade.
Fourth grade, yeah, it is.
And in fifth grade, they're going to be solving multi-step problems. They will be converting even with fractions and decimals in fifth grade.
But it's within a single system, so it's either in the metric system, those things are happening, or customary.
Correct. Here you see the conversion chart, the reference sheet that students will have for assessments. They should also have this reference sheet in front of them during instruction, and we're going to show you one way it can be used a little bit later in the presentation.
Could they have this during the actual assessment?
Yes.
Okay. So even it's on the digital copy, they could access it on the computer, but they could also have a hard copy in front of them. Okay.
So we're going to lead you through concrete to representational to abstract with conversion of customary length. With length, you might want to use color tiles because they are an inch square, a square inch.
So one side is an
inch long. So we would want students to line those tiles up next to the ruler to find out how many inches are in 1 foot. This is something they may come knowing from previous grade levels, but that hands-on experience is going to give them that visual of, oh, it took 12 of these to make 1 foot. And if it takes 12 to make 1 foot, how many is it going to take to make 2 feet?
And so this is really important too, because if students don't understand this conceptually, that reference sheet really doesn't help them a whole lot.
Correct.
In terms of how to apply it.
So now if I'm looking at the reference sheet, 1 foot equals 12 inches matches what they've done with the color tiles.
And then I can also connect that to yards. I could line up those rulers.
We're getting ready to do that on the next slide.
Okay, wow. Okay, I'm anticipating correctly.
And I want you to think about if you're using centimeters and meter sticks, you're probably going to want to use centimeter cubes.
The base 10 cubes.
Base 10 blocks, yes.
Work.
Yep. The next conversion in the customary length conversions is how many feet are in a yard. So how many feet are in 1 yard? I would want them to take those rulers, the 12-inch rulers, and line them up to see how many of them does it take to equal 1 yard. And we can see that 1 yard equals 3 feet. They should be able to find that on their reference sheet.
And there would actually be, if I remember correctly, a lot of the customary yardsticks go to 39 inches.
Because they're meter sticks.
They're meter sticks, so that'll be a conversation. It's like it's not 39.
Yeah, if you're using meter sticks with the inches on the reverse side, you're going to want to mark where 1 yard is, that 1 yard ends at 36 inches, and they can also get that information from the reference sheet. Again, you're going to want to ask them how many feet are in 2 yards, how many in 3 yards, to give them some experience with that being basically multiples of 3 as I'm increasing the number of yards.
Mhm.
Another conversion that's on the reference sheet is that 1 yard equals 36 inches. So we want to give them that experience as well. How many inches are in, or first we're going to look at how many feet are in the 1 yard, which we've done on the previous slide. But then I want to take those inches and how many inches are in 1 foot, Daryl?
12 inches are in 1 foot.
12 inches are in 1 foot. And that means that there are 12 inches in each of those feet, making it a total of how many inches in 1 yard?
36 inches in 1 yard. And you can clearly see just by this concrete model, that's a two-step conversion.
It is a two-step conversion. On the reference sheet, you're going to see that 1 yard equals 36 inches, but that is a double conversion from inches to feet, feet to yards.
Which aligns to the benchmark
Right.
because it is multi-step.
Right. And then I can look at how many are in 2 yards. Again, looking at those multiples of 12s and multiples of 36.
So I could see that 3 yards is equal to, let's see, 36, 3 groups of 36.
Correct, which is 108 inches. Yes. So as students are making these conversions with the concrete tools, it would probably be my expectation in the classroom that they're creating a chart similar to what you see on the screen.
Like a table.
A table that will show me how many inches are in 1 foot, 2 feet, 3 feet, and trying to come up with a rule. What happens when I'm converting from feet to inches? What happens when I convert from inches to feet?
So if they have that concrete model in front of them showing those tables, they could come up with like, okay, well, I'm multiplying by 12 if I'm converting from feet to inches.
Correct.
Because it's 12 inches in 1 foot.
Yes. But if I'm converting from inches to feet, and I know that I have 48 inches.
Then if I see 48 inches, then I know that's 4 feet. I must be dividing because I need fewer of that unit.
Correct. So I'm dividing by 12, 48 divided by 12. I would also want them to create the chart for converting from yards to feet, converting from yards to feet to inches, showing that double conversion. And if I knew that I had 386 inches and I wanted to figure out how many yards, what would I need to do in order to figure that out?
Let's see. So, well, I'm going from a smaller unit to a larger unit. So I'm going to need fewer yards to equal 386 inches.
Correct.
Which means I need to divide. I need to know what the divisor is. So I know that there are 36 inches in 1 yard. So my divisor will be 36.
Correct. And if I convert feet to inches.
Okay, I know my models. I'm going, excuse me, I'm going from a larger unit to a smaller unit. So I'm going to need more of that unit.
Correct.
So that indicates multiplication.
Yes, it does.
So I have to figure out the other factor.
So what am I multiplying 14 feet by?
Well, I know from the first table that 12 inches equals 1 foot. So the other factor is going to be 12.
I would multiply 14 by 12 to get that answer. Yes. All right, so we're going to kind of lead you through how we can use the reference sheet.
Okay.
And come up with a little chart, a little graphic organizer that might help them during assessments.
Okay,
right?
I can't wait to see it.
So I've got my 1 foot equals 12 inches right from the reference sheet. 1 mile equals 1,760 yards. I have all these measurements: feet, inches, yards, miles. Which one's the smallest, Daryl?
The smallest unit would be inches.
And which one's the largest?
It would be the mile.
And with those concrete experiences, I have a visual in my head of which one's the smallest, which one's the largest.
Yes.
So I'm going to order those units from smallest to largest.
And okay, because your entry point could be the small, large. What's in the middle?
Right. Now I'm going to look at what's in the reference sheet. So I'm going to start down here at the bottom and look at 1 mile equals 1,760 yards. So I'm going to put that 1 beside my mile and this 1,760 beside the yards. I know that from the reference sheet. It tells me
Yes.
right there.
Right.
So to get from miles to yards, I have to use that multiplication. I have to take 1 and multiply times 1,760 to get 1,760.
Because I'm going from a larger to a smaller unit, I need more of that smaller unit to equal the larger unit.
Correct. Now, if I'm going the opposite direction and I have 1,760 yards, in order to get to 1 mile,
I got the inverse of multiplication is division.
I've got to divide by 1,760 to get to that mile.
Sure.
Then I can look at another conversion. I'm going to look at yards to feet because that is my next step in, if this was looking at this like a ladder, the next rung in the ladder. So I'm going to go from 1 yard, which equals 3 feet. And if I'm moving from yards to feet, I'm going to
multiply by 3.
And if I'm moving from feet to yards, I'm going to have to do the inverse, which is to divide.
Right.
I'll look at the conversion on the top of my reference sheet, which says 1 foot equals 12 inches. So I'm going to record that 1 foot and 12 inches. And I know to get from feet to inches, I have to multiply 1 times 12 to get that 12. I have to divide. 12 divided by 12 is going to give me that 1 foot.
You know, interesting. I mean, it's hard to think about the concept of a mile, but if students start to see patterns with the smaller units that you could use in the classroom, inches, feet, yards, then they start to see that pattern, and you don't necessarily have to go out and walk a mile. They can see that pattern.
Correct. So when I'm moving from larger units to smaller units, I am multiplying. And when I'm moving from smaller units to larger units, I'm dividing.
But before going to this, they need those concrete experiences.
They do need those concrete experiences first. This is just a representation they can make from what's in the reference sheet.
Yeah, it's almost like a graphic. It's an anchor chart.
It is.
It's an anchor chart.
So going back to the questions from your first task, the first question was how many centimeters are the same length as 6.5 meters or 6 5/10 meters. So what are students going to have to consider as they solve problems like these?
Which unit? Okay, yeah, and there you go. I mean, so you have to think about, well, which unit is smaller, larger? Meters are larger than centimeters.
So am I going to have to multiply or divide to solve?
I think of it in my thought process. I'm going how many centimeters, so I'm going to need more centimeters to equate to 6 5/10 meters. So I'm going to have to multiply.
Right. So then I have to figure it out. I can figure it out by using an equation.
Yes.
And I'm going to use C to represent that missing value, centimeters.
Right.
And I know that I can multiply 6 5/10 times 100 to get that. I could also use the inverse operation. My centimeters divided by 100 is going to give me that 6.5.
And in instruction, this also reinforces the idea of inverse operations with multiplication and division. I would want them to write both equations.
Yes. So looking at the yards and inches, I know that I have 144 inches. I'm going to yards, so I know that I'm going to have to divide because I have the smaller unit. And my equations, I could use multiplication. I know yards times 36 is going to give me that 144. If I'm using division, it's going to be 144 divided by the 36, which gives me the yards.
Yes, and again, have students generate both
equations. This one involves a cups to quarts measurement. Again, cups are the smaller unit, so I am going to use division again to solve. But when the students write the equations, we want them to write both the multiplication and the division equation.
Absolutely.
I'm multiplying 4 times quarts because there are 4 cups in each quart to get that 126. I can use the inverse 126 divided by 4 to get the number of quarts.
And they can label those equations too.
Yes.
What they mean, that would help some students. That's being precise.
Yes. So here we have a conversion that involves a fraction. We've got a mixed number, 3 3/8 of a day, and I'm converting that to the number of hours. So again, I have to think about the larger and smaller units. I know that hours are smaller, days are larger. So I am going to use what operation, Daryl?
So how many hours are in the same amount of time as 3? Okay, so I'm going from a larger unit to a smaller unit. So I'm going to need to multiply.
Correct. So my multiplication equation is going to be 3 3/8 times 24. I want to think about that inverse operation. I could take my number of hours and divide it by 24 to get that 3 3/8.
And an example of labeling would be, well, what is the 3 3/8? It's 3 3/8 of a day times 24 hours per day will give me the total number of hours.
Correct. And here we go back to what they've learned in former units. They've learned how to multiply a mixed number times a whole number, so they can go back to.
And then if I have with division, I have the total number of hours divided by 24 hours per day will give me 3 3/8 days.
Right. It's probably going to give me 3 9/24 of a day. This has just been converted into
simplified form.
Yep. This one might be just a little bit more challenging for students because here I have 6 feet and 4 inches that I'm now converting back to inches.
And I need to think about that as 6 feet 4/12 of a foot.
So I could also think about that as 6 4/12 feet.
Yes.
Right? Again, I need to consider the smaller and larger units. Inches are smaller, feet are larger. I have to also consider with this one, what am I going to do with that extra 4 inches?
That's what makes this a little more challenging. It's like I'm not just converting 6 feet to inches.
So if I'm writing an equation with a variable to represent, I might think about if I'm using multiplication, I know that 6 feet times 12 inches is going to give me the number of inches in that 12 feet.
And that's where many students would get in 5th grade, but the challenge is going to be,
how do I do with those extra 4 inches? Right? So in my equation, I not only have to multiply 6 times 12, but I have to also add those extra 4 inches.
Yes, and they need experience where they have multiple operations in the equation, which connects to multi-step.
Correct. So if I'm going the opposite direction, I have my number of inches, my total number of inches, I'm dividing by 12, and I'm going to get a quotient of 6 4/12.
Yes, and again, both equations.
Correct. Now we have 8 2/3 yards. We're converting to feet. I'm again paying attention to my considerations. I know that yards are a larger unit, feet are the smaller unit.
So I got to multiply.
So I'm going to multiply 8 2/3 times 3 to get the number of feet. And if I'm starting with my feet, I'm going to divide by 3 to get that 8 2/3 yards.
And this is a good application here of area model, if they wanted to figure that out, because I've got length and width, so they should still be able to, figure that. The total feet using multiplication.
Or the distributive property. Correct. Looking at some of the possible misconceptions that students can have, we're going to focus, kind of hone in on that very first one, not having an understanding of the size of different units within the conversion system.
We might, in coaching 5th grade teachers, sometimes we think it's a little silly to have to go back and think about, all right, inches to feet and building those tools. But that's how they develop that understanding and be able to notate that into some sort of equation.
Correct. And so having that visual understanding. I mean, how many students have cooked with their mother in the kitchen or, know what cups looks like and what a pint looks like and a quart looks like? Most students don't know that when they come into your classroom. So we need to give them those concrete experiences to help build that understanding of the size of the different units within each. Within each unit.
Totally.
Yeah. So going back and looking at the CRA approach, we want to
Yep.
make sure that we're giving them those hands-on experiences with the tools
That's the
as
solid understanding.
they build those tables, which are more of a representational. A drawing would also be a representational model. And then moving into that abstract thinking where we're using the multiplication and division to figure out the
Yeah.
equivalent conversions.
Yep.
Thank you for joining us for this edition of Math Dive in 5. We'll see you back next time. Bye-bye.